Hello. So, in this video, we're going to be sort of tackling an idea that's often overlooked, which is that as we sort of continue to add more and more tools to our toolbox for, derivative rules, we can actually sort of unlock new ways of recovering previous tools or sort of re-getting them if we forget them. So the point of this particular video is applying this idea to the quotient rule, which is really one of the most common places where you need that. So in particular, the quotient rule, which we've already done, that's this here, it's sort of relatively nice. It's a little long, but it's not terrible. It's not crazy complicated, but it uses quotients and subtraction, and both of those things are not commutative. So any sort of slight change or mix-up of what term goes where, and you'll inevitably end up with a wrong answer. So the idea here, the idea of this video, is to sort of give you a way of recovering an answer in a way that you don't have to remember which term goes where, without having to go through the crazy process of rederiving the whole quotient rule. So to be clear, we're going to see some computations, and the idea is that these computations are actually computations that you can do, like on an exam or something, on the fly, in order to get back the quotient rule if you don't remember what it was, okay? So a better way to go about this. We have now the product rule, the chain rule, and the power rule, or the polynomial rule, basically a way of taking a derivative of x to the n. And we can use these to recover that quotient rule, to be able to basically take a derivative of quotient in a way that doesn't actually have to worry about what things go where, because the product rule, the quotient rule, and that x to the n derivative, none of those use things that are sort of order specific, right? They all use commutative operations. So the upside here, right, is much easier to get an answer without making a mistake, because you don't have to worry about, having the subtraction in the wrong spot or having dividing by the wrong thing. But nothing's free, so the cost here is that there is indeed more algebra and effort in the actual computation. So again, the idea here is that this is a way of sort of either checking your work, or if you're like, I can't remember which one goes where, this gives you a way of sort of recovering a way of still moving forward and not just, having to guess, basically. So with all that said, let's go ahead. So we start off, we want this derivative of f of x over g of x, and I'm going to be doing this by first rewriting, right? So I'm not doing a derivative, so I still need that d over dx, but I'm rewriting the f of x over g of x by making g of x to the -1 power, right? Because that means that I'm going to have 1 over g of x. So if I have 1 over g of x here times f of x, that is indeed f of x over g of x. So all I've done is rewrite that quotient as being a product, right, times, and using a -1 power. Okay, so now I have the derivative of a product, so I'm going to apply the product rule. So here I'm going to say, okay, I'm going to take the derivative of the first term times just the second term as is, plus the first term as is times the derivative of that second term. Okay, I haven't taken the derivative of the second term yet, but there we go. So now I got to do the derivative of that term. And that is really a composition of functions, right? That's g of x, and then I have that to the -1 power. So I take the derivative of that -1 power, right? I can think of this as u to the -1. So I'm going to subtract 1 from the power and move down that -1. So I have a negative g of x to the -2. And then I have the chain rule, which takes the derivative of the inside, g prime of x. Okay. Now you may think this is starting to look bad, but that's it. That's the thing. We've done it. I know it doesn't look like it, but that really is getting the quotient rule back. Okay, so you might be like, what? So let's take a look. First, let's notice that none of the derivative rules we applied need to worry about the order of terms, right? So when we are doing this process, right, whether or not you remember, like, okay, is it the first term is the derivative and then that one, or is it the other one first? Well, this is an addition, so it doesn't matter which of these you place where, right? So all of this process is commutative, so you don't have to worry about remembering which one goes where as long as you remember sort of the basic rule. And you might notice that like in the quotient rule, we had a negative, so a negative has to show up somewhere, and that's one of the things that's not commutative. Here, the negative shows up as a result of that chain rule and the fact that we're doing a -1 power here. So it attaches itself to the correct term automatically as part of that chain rule. So we don't actually have to remember where it goes. It comes out naturally as this process. Finally, to actually get the quotient rule, because admittedly this right here looks nothing like the quotient rule that we're familiar with, there is a little bit more work that we can sort of do. So we can find a common denominator and rewrite the negative powers as fractions and put it together. So I'll do that part in just a second. But to be clear, this isn't something you would need to do in your own work, right? You could, in your own work, you have an actual concrete f and an actual concrete g, and you would compute this out and you get some function at the end. And if that is sort of sufficient to move along, just move along. You don't have to get it to look like the quotient rule if you can sort of do whatever else you're trying to do in your problem. But nonetheless, right, my claim is this is equivalent to the quotient rule, so I want to show that in this video specifically. So let's go back to where we were. So we got to this point, and my claim is that we don't have to do any more calculus to get the quotient rule. So the next step then, right, I'm going to take this thing, that's where we were, and the first thing I'm going to do is convert those negative exponents to a fraction, right? So this g of x to the -2, I'm going to make that 1 over g of x to the 2, g of x squared. And that leaves me with a negative g prime in the top and an f of x in the top. Here, I have this thing to the -1, so that's going to become 1 over g of x times f prime. So I have f prime of x over g of x. Now, I have two fractions that are a little bit different, so I need a common denominator. In particular, I need another g of x on this side, so I'm going to multiply the top and bottom by g of x. That gets me f prime of x g of x over g of x squared. And just for the sake of cleanliness, I'm going to take this negative and sort of pull it out a little bit. So I have negative f of x g prime of x. But now I have two things, common denominator, put them together, and lo and behold, there is our quotient rule. It's right there. So all I had to do was do some sort of relatively basic arithmetic to put all this stuff together. Granted, in the format that it's in, it looks kind of crazy because it's all f's and g's and not, x squared or something. But it's the same sort of idea. There was no more derivatives to take. There was no more calculus, no limits, none of that. It was just, basic manipulations. So what did we do? So we developed sort of the key idea here is we developed another way to take a derivative of a quotient, but not just for no reason. We did one that doesn't require us to remember the order of stuff, right? We don't have to remember what goes where because it sort of takes care of it all for us. And all of the sort of things that we did were commutative. They all can go in whatever order we want, so it doesn't take as much sort of mental memory. So this is sort of a fallback if you're doing an exam or something where you can't look it up and you need to remember how to do a derivative of a quotient, but you can't remember the quotient rule. This is a way you can do it, right? Do a product rule and a chain rule. So clearly the downside is that this does take more algebra, right? This isn't one of those things where it was, start with a thing at the top, move all the way down, and remember the thing at the bottom and sort of not worry too much about the middle. Like the whole point of this video is that you would have to do that stuff in the middle. So there is some algebra and it's sort of not as nice and elegant. But if you're in a bind, you can't remember the quotient rule, this gives you another way. You don't have to just guess or get the problem wrong or whatever. There is a way of recovering it. And that's the sort of helpful takeaway here. Okay? So that is that.